Picture the most beautiful planet in the solar system. Golden rings stretching hundreds of thousands of kilometers across the void. A pale butterscotch sphere floating in perfect stillness against the black of space. Every child draws it. Every textbook celebrates it. Saturn is the jewel of our cosmic neighborhood, but that image is a lie. Beneath those delicate rings hides a world of 1,000-mile-per-hour winds, crushing pressures that would squeeze metal into liquid, and storms so violent they flash with lightning, 10,000 times more powerful than anything on Earth. Saturn is not what it seems. It never was. What you think you know about this planet is the most beautiful deception in the entire solar system. And tonight, we tear it apart. If you enjoy science that challenges what you thought you knew, a like and subscribe genuinely helps this channel keep going. Are you comfortable? Now, let's begin. There is a planet in this solar system that has been lying to you for your entire life. Not through any intention, not through any trick of engineering or alien design. It has been lying the way a perfectly still ocean lies when it hides a riptide underneath. The way a snow-covered field lies when it conceals a crevasse deep enough to swallow a building. Saturn has been lying through sheer beauty. And you believed it because every image you have ever seen of this planet was designed by accident or by framing to make you believe it. Close your eyes for a moment and picture Saturn. What do you see? You see gold, you see rings, you see something that looks like a piece of jewelry suspended in the black of space, spinning slowly, catching starlight along the edges of those impossibly thin bands of ice and rock that stretch outward from its equator like the brim of an enormous hat. The image is so clean, so geometrically precise, so visually perfect that it does not feel like a planet at all. It feels like a symbol, an icon, something a graphic designer would create to represent the concept of space itself. That is the problem. Because the image in your mind is not wrong, Saturn really does look like that from a distance. The photographs are not doctored. The colors are roughly accurate. The rings are real. The proportions are honest. Nothing about the visual record of Saturn is a fabrication. And yet everything about it is misleading, because what you are looking at when you see a photograph of Saturn is a mask, a shell, a surface layer so visually striking that your brain does something it is not supposed to do. It stops asking questions. It accepts the image as the complete story. And the complete story of Saturn is something so different from that golden postcard that the gap between them might be the largest deception in planetary science. To understand how deep that deception runs, you need to go back to the beginning. Back to the moment humans first looked at Saturn through something more powerful than their own eyes and immediately got the wrong answer. In 1610, Galileo Galilei aimed his telescope at Saturn and saw something he could not explain. The planet appeared to have companions, two smaller objects, one on each side, pressed up against the main body like ears on a head. He described Saturn as having a triple form. He sketched it carefully. He told his colleagues. And then, 2 years later, when he looked again, the companions had vanished. Saturn appeared perfectly round, alone, as if nothing had ever been there. By 1616, the companions returned, but now they looked different, broader, more like handles than moons. Galileo was baffled. He drew what he saw and moved on to other problems, never fully understanding what he had been looking at. It took another 45 years for a Dutch astronomer named Christian Huygens to solve the puzzle. Using a telescope, he had ground himself, with significantly better optics than anything Galileo had access to. Huygens realized that the strange shapes flanking Saturn were not moons and not handles. They were a ring. A thin, flat disk of material encircling the planet at its equator tilted relative to Earth's line of sight, which meant that as Saturn moved through its orbit, the ring appeared to change shape. When viewed edge-on, it vanished entirely because it was so thin. When tilted, it spreads wide, creating the appearance of arms or lobes. The mystery that had confused astronomers for nearly half a century dissolved in a single insight. Saturn was surrounded by a ring unlike anything else known in the heavens, and from that moment forward, the ring became the story. The ring became the identity. Saturn was not just a planet. It was the planet with the ring, the one that looked different, the one that stood out in every diagram, every textbook, every classroom poster of the solar system. Children learned to draw it before they could spell it. Artists used it as shorthand for the cosmos itself. For centuries, Saturn occupied a place in the human imagination that was built almost entirely on appearance. A beautiful ringed world floating in the outer darkness, elegant, remote, serene. Then, in the late 20th century, we sent machines to go and look. The first spacecraft to reach Saturn was Pioneer 11. It arrived on September 1st, 1979, passing within 21,000 kilometers of the cloud tops at a relative velocity of 114,000 kilometers per hour. Pioneer 11 was a small spacecraft, lightweight, spin-stabilized, and equipped with instruments designed in the late 1960s. Nobody knew what it would find. Nobody even knew whether the ring plane could be safely crossed. One of Pioneer 11's primary objectives was simply to determine whether a spacecraft could fly through Saturn's ring system without being destroyed, so that the more sophisticated Voyager probes, already on their way, would know the path was clear. Pioneer survived. And in its brief flyby, it returned 440 images of Saturn, and its system discovered a new ring, the F ring, found 2 previously unknown moons, and provided the first direct evidence that Saturn possessed a magnetic field. It measured the planet's temperature at approximately -180 degrees Celsius. It confirmed that the atmosphere was primarily hydrogen, and the photographs it sent back, grainy and low resolution by modern standards, showed a planet that looked quieter and more featureless than Jupiter. Smoother, calmer, more refined. That initial impression set a tone that would persist for decades. Saturn appeared subdued. Compared to Jupiter's bold, contrasting bands and the angry red bruise of the Great Red Spot, Saturn's cloud patterns were muted. The colors were soft. The banding was subtle. Pioneer 11's instruments were not sensitive enough to detect the violence hidden beneath that calm exterior, and the images reinforced what the eye already wanted to believe. Saturn was the gentle giant, the elegant one. A year later, Voyager 1 arrived. Voyager 1 was a far more capable spacecraft, carrying cameras with dramatically higher resolution and a suite of instruments that could probe the atmosphere, the magnetic field, the rings, and the moons in detail that Pioneer had never approached. Voyager 1's closest approach to Saturn occurred on November 12, 1980. The images it returned were stunning. The rings resolved into hundreds of individual ringlets, intricate and impossibly detailed, like the grooves on a vinyl record magnified to planetary scale. The colors of the atmosphere, while still muted compared to Jupiter, revealed subtle structure, faint bands, wispy storm features, and hints of complexity that the eye could appreciate but the brain filed as gentle. But Voyager 1's instruments were telling a different story. The data showed wind speeds in Saturn's equatorial atmosphere reaching 500 meters per second, 1,800 kilometers per hour. These were not gusts. These were not peaks in a storm. These were the sustained, baseline, permanent winds of Saturn's equatorial jet stream. The numbers were so high that some researchers initially questioned whether the measurements could be correct. They were correct. Saturn's winds were nearly 5 times faster than the most powerful hurricanes on Earth, and they were blowing all the time. Voyager 2 followed in August 1981, refining the measurements and capturing even more detail. Together, the 2 Voyager spacecraft provided the first comprehensive portrait of Saturn's atmosphere. They detected temperature variations, tracked cloud features to measure wind speeds at multiple latitudes, discovered the hexagonal structure at the North Pole that would later captivate scientists for decades, and recorded radio emissions consistent with lightning discharges deep in the atmosphere. Voyager 1's instruments also detected what appeared to be Saturn electrostatic discharges, powerful bursts of radio energy that scientists initially could not determine were coming from the atmosphere or from the rings. The signals were intense, they were frequent, and they were consistent with electrical discharges on a scale that dwarfed anything known on Earth. But here is the detail that reveals the depth of Saturn's perceptual trick. The Voyager data on wind speeds, lightning, and atmospheric structure was published in scientific journals. It was discussed in technical conferences. It was reviewed by specialists in planetary atmospheres and fluid dynamics. And then, almost without exception, it was eclipsed by the photographs. The newspapers did not run headlines about 1,800 km/h winds. They ran photographs of the rings. The television broadcasts did not lead with the discovery of electrostatic discharges powerful enough to light up cloud regions 200 kilometers across. They led with images of Saturn's crescent, backlit by the sun, glowing like a lantern in the void. The public response was predictable and entirely human. People saw what they wanted to see. They saw beauty. Scientists published papers about 1,800 km/h winds, and the world hung posters of Saturn's rings on bedroom walls. This is the pattern. This is how Saturn has operated in the human imagination for 4 centuries. Every time technology allows a closer look, the instruments detect violence, and the cameras capture beauty, and the beauty wins. Every time. Then Cassini arrived. The Cassini-Huygens mission launched in 1997 and entered orbit around Saturn on July 1, 2004. It would spend 13 years studying the planet, its rings, and its moons in a level of detail that no previous mission had come close to achieving. It carried 12 scientific instruments. It completed 294 orbits. It downlinked more than 300,000 raw images. It discovered 6 new moons. It dropped the Huygens probe through the atmosphere of Titan and landed it on the surface, marking the first landing ever achieved in the outer solar system. It flew through the ice geysers of Enceladus. It measured the structure of the rings down to scales of meters. It mapped the magnetic field, sampled the atmosphere, and tracked storms across latitudes for over a decade. Cassini was, by almost any measure, one of the most successful planetary science missions in human history, and the images it sent home were breathtaking. Saturn backlit by the sun, its rings glowing like halos of spun glass. Saturn at equinox, with the rings casting razor-thin shadows across the cloud tops. Saturn in natural color, pale golden cream, banded in soft horizontal stripes that looked more like watercolor than weather. The photographs were shared millions of times. They appeared in documentaries, in magazines, on the walls of classrooms and the screens of phones. They cemented Saturn's place in the public imagination as the most beautiful planet in the solar system. The jewel, the crown, the one that made people pause and feel something close to wonder. In its final months, Cassini executed a series of maneuvers called the Grand Finale. 22 daring dives between Saturn's innermost ring and the outer edge of its atmosphere. These orbits took the spacecraft closer to Saturn than any human-made object had ever been. During those passes, Cassini sampled the outermost wisps of the atmosphere directly, tasting the chemistry of the upper cloud deck with its instruments. It measured the gravity field with enough precision to constrain the depth of the wind systems and the structure of the deep interior. It mapped the magnetic field from closer range than ever before. And on September 15, 2017, Cassini made its final plunge into Saturn's atmosphere, transmitting data for 30 seconds longer than engineers had expected before the planet consumed it. The spacecraft that had spent 13 years revealing Saturn's secrets became part of the planet itself, burned and compressed into the hydrogen atmosphere, its atoms scattered into the winds. The data from the grand finale confirmed something scientists had suspected but could not previously prove. Saturn's winds extend thousands of kilometers below the visible cloud tops. The atmospheric violence, visible in photographs, is not a surface phenomenon. It reaches deep into the planet, driven by internal heat and coupled to the structure of the interior in ways that are still being untangled. The grand finale showed that the boundary between Saturn's atmosphere and its interior is not just blurred, it is non-existent. The wind and the planet are the same thing. Here is what those images did not show you. They did not show you that the clouds you were admiring are made of ammonia ice crystals suspended in an atmosphere of hydrogen and helium that extends downward for tens of thousands of kilometers with no surface, no floor, and no bottom. They did not show you that beneath those pastel bands, the atmosphere moves at speeds that would strip the wings off any aircraft ever designed. They did not show you that the gentle-looking stripes are actually the visible tops of jet streams, so powerful that they would shred any structure ever built by human beings in a fraction of a second. They did not show you that the planet has no ground, that if you descended into it, you would never land. You would simply fall deeper and deeper through thickening gas that slowly crushes you, heats you, and transitions around you from vapor into liquid, into something that is no longer a gas or a liquid in any way you would recognize. They did not show you that the pressure at the depths of Saturn reaches millions of times the atmospheric pressure at sea level on Earth, enough to compress hydrogen itself into a metallic state, a form of matter so exotic that it barely exists anywhere in the natural universe outside the interiors of giant planets and certain categories of dead stars. They did not show you any of that because cameras cannot photograph pressure. Cameras cannot photograph wind in the dark. Cameras cannot photograph the slow transition from breathable nothing into a crushing ocean of liquid metal that would destroy any object ever manufactured by human civilization before it reached even a fraction of the way to the partless center. What cameras can photograph is the top of the atmosphere, the thin visible shell, the mask, and the mask is gorgeous. This is the core of Saturn's deception. It is not hiding anything on purpose. It is simply a planet whose external appearance has almost no relationship to its internal reality. The beauty is real, but it is a surface phenomenon, like the shimmer on a soap bubble. It tells you nothing about what is underneath, and what is underneath is one of the most violent, hostile, and alien environments in the entire solar system. Consider what you are actually looking at when you see a photograph of Saturn's cloud tops. You are seeing the upper boundary of an atmosphere that is approximately 96% molecular hydrogen and roughly 3% helium. That atmosphere does not sit on top of a rocky planet the way Earth's atmosphere sits on top of land and ocean. Saturn's atmosphere is the planet. There is no dividing line between the sky and the world. The gas simply thickens as you descend, increasing in temperature and pressure with every kilometer, until at some point, deep inside, the hydrogen is compressed into a liquid. Deeper still, the pressure forces that liquid into a metallic phase. And at the very center, There may be a rocky core, perhaps 15 to 20 times the mass of Earth, but it exists under conditions so extreme that no probe, no instrument, and no material known to science could survive there. The planet you are looking at in those photographs is a shell wrapped around an abyss. And the shell is the only part that looks like anything you would want to visit. Now, consider what Saturn's density tells you about its nature. Saturn is the least dense planet in the solar system. Its average density is approximately 0.69 grams per cubic centimeter. Water, for comparison, has a density of 1 gram per cubic centimeter. This means that if you could find a body of water large enough, Saturn would float. That fact appears in nearly every popular science article about the planet. It is presented as charming, delightful. A fun fact for children: Saturn is so light it could float in a bathtub. But think about what that actually means for a moment. You are looking at a planet that is 95 times more massive than Earth, a world so large that 764 Earths could fit inside its volume, and its average density is lower than water. The only way that is possible is if the vast majority of the planet is made of the lightest elements in the universe, compressed into states that range from thin gas to crushing liquid to electrically conductive metal, with almost no solid material anywhere except possibly at the very core. This is not a planet in any intuitive sense of the word. It is a sphere of compressed atmosphere, wrapped around a tiny seed of rock and ice, held together by gravity alone. There is nothing solid to stand on. There is nothing solid to crash into. There is only gas becoming liquid, becoming metal, becoming heat, becoming pressure, becoming darkness, and the whole thing is spinning, fast. Saturn completes one full rotation in approximately 10 hours and 42 minutes. That is less than half the time it takes Earth to turn once. A day on Saturn is shorter than a night's sleep on Earth. That rotational speed has consequences. It flattens the planet. Saturn is visibly oblate, meaning its equator bulges outward while its poles are compressed. The equatorial diameter is roughly 9.5 times Earth's, but the polar diameter is noticeably smaller. You can see this in photographs if you know what to look for. The planet is not a perfect sphere. It is a squashed sphere, wider than it is tall, because it is spinning so fast that centrifugal force at the equator pulls material outward. That same rotational speed drives the wind systems that define Saturn's atmosphere. And those wind systems are where the beauty starts to crack. From a distance, Saturn's cloud bands look like soft stripes painted in muted tones. Pale gold, cream, ochre, the faintest hints of blue near the poles when the geometry of sunlight is just right. The banding is subtle compared to Jupiter's bold, contrasting stripes. Saturn looks calmer, quieter, more refined. If Jupiter is the loud, aggressive sibling, Saturn is the poised, elegant one. That is the impression. And it is completely wrong. The bands you see in Saturn's atmosphere are the visible expression of alternating jet streams that circle the entire planet. At the equator, winds blow eastward at speeds that Voyager data measured at up to 500 meters per second. That is 1,800 kilometers per hour. To put that in perspective, the strongest sustained winds ever recorded in an Earth hurricane peak at roughly 360 kilometers per hour. Saturn's equatorial winds are 5 times that speed. They are not gusts. They are not occasional peaks in a storm. They are the permanent, sustained, baseline wind speed of the equatorial atmosphere. They never stop. They never weaken below a level that would obliterate any human structure. They have been blowing at roughly this speed for as long as we have been able to measure them, and almost certainly for far longer than that. At higher latitudes, the wind pattern becomes more complex, but no less violent. Alternating jet streams circle the planet in bands, some blowing east, some blowing west, with speeds that vary between roughly 150 and 400 meters per second, depending on latitude. The boundaries between these opposing jet streams are shear zones, regions where air masses moving in opposite directions at hundreds of kilometers per hour grind against each other. The turbulence generated at these boundaries produces eddies, vortices, and rolling structures that can grow to enormous sizes. Some of these vortices persist for months or years, spinning at the edges of the jet streams like ball bearings caught between two conveyor belts moving in opposite directions. Cassini tracked these features over 13 years and found them to be remarkably persistent. Storms would appear, grow, interact with the jet streams, and either be absorbed back into the flow or stabilize into long-lived vortices that drifted with the prevailing winds. The atmosphere was never still. It was never quiet. At every latitude, at every longitude, at every altitude that Cassini's instruments could probe, Saturn's atmosphere was in constant, violent, organized motion. Now, step back. Look at the photograph of Saturn again. See the soft gold. See the gentle stripes. See the rings catching the light. See the elegant shape, the quiet poise, the sense of stillness. None of that is real in the way your brain interprets it. What you are looking at is a world where the calmest day would kill you faster than any environment on Earth. Where the gentlest breeze moves at a speed that would tear a commercial airliner apart in less than a second. Where the atmosphere has no bottom and the pressure at depth would crush a nuclear submarine into a pellet of scrap metal smaller than a coin. Where there is no surface, no land, no ocean, no horizon, only an endless descent into thickening gas that becomes liquid, that becomes metal, that becomes heat so intense it rivals the outer layers of a star. Saturn is not what it looks like. It never was. And the reason most people do not know this is precisely because the planet is so beautiful that no one ever thinks to ask what is behind the beauty. The rings draw your eye. The colors soothe your expectations. The proportions satisfy something deep in the human sense of visual harmony. And so the brain does what brains do when presented with something that looks safe and symmetrical and golden. It relaxes. It files Saturn away as elegant, majestic, peaceful. The Voyager spacecraft should have broken that illusion. They flew close enough to measure the winds, detect the storms, and record the first signs of atmospheric violence hidden beneath the pastel clouds. But the images they sent back were so stunning that the violence was lost behind the beauty. Cassini should have shattered it completely. 13 years of continuous observation produced a dataset that describes one of the most hostile atmospheric environments ever studied. But the photographs were so perfect, so endlessly shareable, that the data was overwhelmed by the aesthetics. This is Saturn's trick, not a trick of physics, but a trick of perception. The planet is genuinely dangerous. The data proves it. The measurements confirm it. The atmospheric models describe a world that would destroy anything we could send into it within minutes of descent. And yet every time someone shows you a picture of Saturn, your response is not fear. It is awe. It is admiration. It is the quiet, satisfied feeling of looking at something beautiful. That response is the lie, not the planet's lie. Yours. Saturn does not care what you think of it. It is not performing. It is not posing for photographs. It is a sphere of compressed gas, 95 times the mass of your world, spinning through the outer solar system at 9.7 kilometers per second, radiating more energy than it receives from the sun, generating a magnetic field that extends millions of kilometers into space, and driving wind systems that have been operating without interruption for longer than complex life has existed on Earth. It does none of this for your benefit. It does none of this with any awareness that you exist. It simply is what it is. And what it is bears almost no resemblance to what you think it is. What comes next will take you below the cloud tops, into the atmosphere, through the layers where light fades and pressure builds, and the familiar chemistry of the upper atmosphere gives way to something far stranger. You will learn what happens when ammonia ice gives way to ammonium hydrosulfide, when water clouds boil in the dark, when hydrogen compresses beyond anything the surface of Earth has ever produced, and when storms erupt with a violence that can reshape the visible face of an entire planet in a matter of weeks. The beautiful image is about to come apart. And what you find underneath will change how you see Saturn permanently. You are now going to descend into Saturn's atmosphere, not physically. No spacecraft ever built could survive what you are about to experience. No spacecraft ever designed has been intended to try. But in your mind, you are going to fall through the cloud tops of the most deceptively beautiful planet in the solar system. And what you encounter on the way down will permanently change the way you look at every photograph of Saturn you have ever seen. Start at the top, the very top. You are floating at the edge of Saturn's upper atmosphere, roughly at the altitude where the pressure is about 1/10 of a bar, which is about 1/10 of the atmospheric pressure at sea level on Earth. The temperature here is approximately -189 degrees Celsius. That is cold enough to freeze carbon dioxide solid, cold enough to kill any unprotected human in seconds. But this is the warmest welcome Saturn will ever give you. Everything from here goes in one direction, and that direction is worse. At this altitude, you are surrounded by a thin haze of hydrogen and helium with trace amounts of methane, ammonia, and other compounds. The sky above you, if you could look up, would show nothing but black space and the faint, distant sun, which, from Saturn's orbit, appears roughly 1/100th as bright as it does from Earth. Sunlight here is weak, dim, the kind of light you would associate with deep twilight. It is enough to illuminate the upper cloud layers below you, barely, and to drive the photochemistry that produces the thin, organic hazes drifting in the stratosphere. But it is not enough to warm anything. Now begin falling. Within the first few 100 kilometers of descent, you pass through the stratosphere and into the troposphere, the region where weather occurs. The temperature rises as you go deeper, the pressure increases, and the first cloud deck appears below you like a floor you cannot land on. This is the ammonia ice cloud layer, sitting at pressures of roughly 1/2 bar to 1 bar. These are the clouds you see in every photograph of Saturn. These are the pastel bands. These are the soft gold and cream stripes that make the planet look like a watercolor painting suspended in space. They are made of frozen ammonia. Ammonia, on Earth, is a toxic gas. It burns the eyes. It sears the lungs. It is used in industrial cleaning products and refrigeration systems, and exposure to concentrated ammonia vapor can cause chemical burns to the respiratory tract within seconds. On Saturn, ammonia freezes into tiny crystals at the temperatures and pressures of the upper troposphere, and those crystals form clouds. The beautiful golden color that defines Saturn's visual identity comes from these ammonia ice particles, tinted by trace amounts of other compounds, possibly phosphorus or sulfur-based molecules, whose exact identity is still debated. The specific chemistry that produces Saturn's color palette remains one of the open questions in planetary science. What is not debated is what the clouds are fundamentally made of. Frozen poison, drifting in bands that circle the entire planet at speeds no earthly wind has ever approached. And this is where the wind hits you. You already know the numbers from the Voyager data. 500 meters per second at the equator, 1,800 kilometers per hour. But numbers on a page and wind against a body are not the same thing. At these speeds, the atmosphere is not air. It is a weapon. The dynamic pressure of a 500 meter per second hydrogen wind would not push you sideways. It would disassemble you. Any physical object placed in that flow would experience aerodynamic forces so far beyond its structural capacity that the failure would not resemble being blown over. It would resemble being sandblasted into fragments at the molecular level. And this is the equator. At higher latitudes, the alternating jet streams create shear boundaries where adjacent bands of atmosphere grind in opposite directions. These boundaries spawn vortices that grow to continental scales and persist for years, feeding on the energy differential between the opposing flows. But all of that is the ordinary weather, the background hum of atmospheric violence that Saturn produces every single day without interruption. What happens when Saturn has an actual storm makes the background look like a gentle breeze. Before the great white spots, though, there is the matter of Saturn's everyday lightning. Because even between the major eruptions, Saturn's atmosphere crackles with electrical violence on a scale that dwarfs anything on Earth. Cassini's radio and plasma wave science instrument began detecting Saturn electrostatic discharges almost immediately after. Arriving in orbit in 2004, these are the radio signatures of lightning, bursts of electromagnetic energy produced by electrical discharges deep in the atmosphere. Unlike lightning on Earth, which occurs across many latitudes and in countless simultaneous storms, Saturn's lightning during the Cassini era was concentrated in a remarkably narrow band. For years, virtually all detected lightning came from a strip of atmosphere at roughly 35 degrees south latitude, a region that scientists came to call Storm Alley. Storm Alley produced thunderstorms that would erupt, rage for weeks or months, and then subside, only to be replaced by another storm in roughly the same location. Cassini tracked these storms through their radio signatures, detecting electrostatic discharges that lasted fractions of a second each, but repeated constantly, like the static on an AM radio tuned between stations. The individual discharges were powerful. Saturn's lightning bolts carry approximately 1,000 times the energy of a terrestrial lightning flash. Some estimates from the radio data suggest they can be 10,000 times more powerful. Each flash illuminates a cloud region roughly 200 kilometers in diameter, and the flashes originate deep in the atmosphere, approximately 125 to 250 kilometers below the visible cloud tops, most likely in the water cloud layer where convective energy is greatest. Think about what that means. The lightning you see on Earth, the kind that splits a tree or sets a field on fire, is 1,000th the power of what Saturn produces routinely in a single bolt. And Saturn produces thousands of these bolts per storm, in storms that last for months, in an atmosphere so deep and so opaque that the visible flash has to diffuse upward through more than 100 kilometers of cloud before it can even be seen from above. Most of the violence is invisible. Most of the energy is absorbed by the atmosphere itself. What reaches the cloud tops and can be detected by a camera is a faint glow, a distant shimmer of something catastrophic happening far below. Cassini captured the first optical images of Saturnian lightning during the August 2009 equinox, when the sun illuminated the ring's edge on, and the planet's night side was darker than usual. The flashes appeared as brief pinpricks of light within the cloud deck, each one the visible remnant of a discharge that had released more energy than a nuclear detonation. The flashes were correlated precisely with the radio bursts, confirming that what the instruments had been hearing for years was genuine atmospheric lightning, originating deep in Saturn's water clouds and operating at power levels that make terrestrial thunderstorms look like static electricity. The chemistry of this lightning is itself extraordinary. When a bolt of Saturnian lightning strikes, it heats the surrounding gas to temperatures exceeding 30,000 degrees Celsius. At those temperatures, the methane, ammonia, hydrogen sulfide, and water vapor present in the deep atmosphere undergo pyrolytic chemistry. The lightning literally cooks the atmosphere, breaking molecules apart and forging new compounds. Research by Kevin Baines and Mona Delitsky found that lightning discharges in Saturn's methane-rich environment can reduce hydrocarbons to elemental carbon, producing soot. Repeated discharges yield solid carbon, acetylene, and a complex soup of organic compounds incorporating sulfur, nitrogen, and phosphorus. The dark clouds, observed by Cassini's visual and infrared mapping spectrometer in the vicinity of thunderstorms, are consistent with these carbon-rich products being lofted from the deep atmosphere by convective updrafts deposited at the visible cloud tops. Saturn's lightning does not just illuminate the atmosphere, it transforms it. Every bolt is a chemical factory, operating at 30,000 degrees, manufacturing soot and exotic organic compounds in the darkness below the visible clouds. The beautiful golden surface that you see in photographs is, in part, painted by the chemical fallout of electrical violence occurring hundreds of kilometers below. Now consider what happens when the ordinary storms give way to something truly extraordinary. Every 20 to 30 Earth years, something erupts in Saturn's atmosphere that is so enormous, so violent, and so visually dramatic that it can be seen from Earth through amateur telescopes. Scientists call these events great white spots. 6 have been observed since 1876. They are Saturn's version of a planetary tantrum, and they are unlike anything else in the solar system. The most recent great white spot erupted on December 5, 2010. At approximately 35 degrees north latitude, Cassini was in orbit. For the first time in history, a spacecraft was present to watch one of these eruptions unfold from start to finish. What Cassini saw was staggering. The storm began as a small bright cloud, roughly 800 miles across. Within weeks, it had grown to a latitudinal extent of approximately 10,000 kilometers. Within 2 months, the storm's tail had wrapped entirely around the planet, encircling Saturn in a band of churning white cloud that covered approximately 2 billion square miles. To put that in perspective, the storm eventually affected nearly 20% of Saturn's entire northern hemisphere. If an equivalent storm occurred on Earth, it would blanket most of North America from coast to coast and then keep going until it circled the globe. The storm remained actively convecting for more than 200 days, making it the longest-lived planet-encircling tempest ever observed on Saturn. The previous comparable storm, observed in 1990 by the Hubble Space Telescope, lasted only 55 days. The 2010 event was something else entirely. Cassini's radio and plasma wave science instrument detected lightning within the storm at rates 10 times higher than any previous Saturnian storm the spacecraft had observed. At the peak of activity, flashes were occurring at a rate of more than 10 per second, so frequently that the instrument could no longer resolve individual discharges. The storm had become a continuous electrical roar. The storm was not just an atmospheric disturbance, it was a thermal event. Cassini's composite infrared spectrometer detected a massive surge of energy that sent temperatures in Saturn's stratosphere soaring by approximately 83 degrees Celsius above normal. That is an unprecedented temperature spike for any planet. The energy released by the storm was so intense that it produced a phenomenon scientists described as a stratospheric beacon, a concentrated hotspot of heat that persisted for months after the visible storm had subsided. The beacon was accompanied by an enormous release of ethylene gas, a compound that should not have been present in those quantities at those altitudes, suggesting that the storm's convection had dredged material from deep within Saturn's interior and flung it into the upper atmosphere with extraordinary force. Andrew Ingersoll, A Cassini imaging team member at the California Institute of Technology described the storm as more like a volcano than a terrestrial weather system. "The pressure builds up for many years before the storm erupts," he said. "The mystery is that there is no rock to resist the pressure, no solid barrier to delay the eruption for so many years. And yet, the eruption is delayed. For decades, Saturn's atmosphere suppresses convection in a way that stores energy deep in the interior, and then releases it all at once in an event so powerful it reshapes the visible face of the entire planet." The mechanism behind this suppression was proposed by Ingersoll and his graduate student Cheng Li. They found that the weight of water molecules in Saturn's atmosphere, which are heavier than the hydrogen and helium that dominate the planet's composition, plays a critical role. When water rains out of the upper atmosphere, it makes the remaining gas lighter, which suppresses further convection. Over time, the upper atmosphere cools. Eventually, the cooling overcomes the suppression, and warm, moist air from below erupts upward in a catastrophic convective event. The cycle takes roughly 20 to 30 years to complete, which matches the observed periodicity of the Great White Spots. The storm head itself, the active region where convection is most violent, was analyzed in detail using high-resolution Cassini imagery from February 2011. Scientists found strong winds organized into a divergent, open anticyclone where massive cumulus-like cloud clusters punched upward through the surrounding atmosphere. The cloud tops in the storm head rose approximately 44 kilometers above the undisturbed environment around them, driven by convective updrafts so powerful that they lofted water, ice, and ammonia from the deep atmosphere all the way to the visible cloud deck. The storm head periodically spawned large anticyclonic vortices that drifted eastward, each separated by roughly 10 to 15 degrees of longitude, creating a chain of spinning storm cells that wrapped around the planet like beads on a string. The interaction between these vortices and Saturn's pre-existing jet streams generated turbulence on scales that researchers described as unprecedented in the observational record of any planet. Think about what that means. Saturn's atmosphere stores energy for decades, building pressure in a system with no solid surface, no containment vessel, no geological structure to hold anything in place, and then releases it in a single eruption that wraps the planet in a storm larger than Earth. The entire mechanism is driven by atmospheric dynamics alone. There is no volcano, there is no tectonic plate. There is just gas, pressure, and time. Now, turn your attention to the poles. Because what Saturn does at its poles is perhaps the single strangest atmospheric phenomenon in the known solar system. At Saturn's north pole, there is a hexagon, not a roughly hexagonal shape, not an approximation that looks vaguely six-sided if you squint. A geometrically precise hexagonal jet stream with 6 nearly equal sides and 6 nearly equal angles spinning around the north pole of the planet with a regularity that looks engineered. Each side of the hexagon is approximately 14,500 kilometers long, which is longer than the diameter of Earth. The entire structure spans roughly 29,000 kilometers across. You could fit 2 Earths side by side inside it. The hexagon was first observed in images from the Voyager missions in 1981. When Cassini arrived at Saturn more than 20 years later, the hexagon was still there, unchanged in shape, unchanged in size, rotating with a period of 10 hours, 39 minutes, and 24 seconds, which matches the rotation period of Saturn's deep interior. It does not drift in longitude the way other cloud features do. It is locked to the planet's internal rotation as if it were bolted to the core itself. Inside the hexagon sits a massive cyclonic vortex centered directly on the North Pole. This polar vortex resembles a hurricane, with a clearly defined eye and spiraling cloud bands, but it is not a hurricane in any terrestrial sense. Earth's hurricanes are powered by warm ocean water. Saturn has no ocean. Saturn has no surface. This vortex is powered entirely by atmospheric dynamics and internal heat, and it has been spinning for at least as long as humans have been able to observe it, which is more than 40 years. Surrounding the central vortex, within the hexagonal boundary, are numerous smaller vortices. Some spin clockwise, some counterclockwise. The largest of these embedded storms spans approximately 3,500 kilometers across, which is roughly twice the size of the largest hurricane ever recorded on Earth. These subvortices are swept along by the hexagonal jet stream like debris caught in a current, orbiting the pole in a formation that looks almost deliberately arranged. A study published in Nature Communications in 2018 found that the hexagonal structure extends much higher into the atmosphere than originally expected. As Saturn's northern hemisphere moved into summer and the pole received more sunlight, a warm stratospheric vortex began to form above the tropospheric hexagon. The boundary of this emerging stratospheric vortex was also hexagonal, suggesting that the Rossby wave responsible for the hexagon's shape extends vertically through the atmosphere for at least 300 kilometers, from the cloud tops deep in the troposphere up into the stratosphere. The hexagon is not a surface feature. It is a three-dimensional atmospheric structure that towers above the cloud deck like an invisible skyscraper made of wind. Physicists at the University of Oxford attempted to recreate the hexagon in a laboratory. Ana Claudia Barbosa Aguiar and Peter Red built a rotating tank filled with water and placed a small ring inside it that could spin independently of the outer cylinder. When the ring spun faster than the surrounding fluid, it generated a jet stream between the two rotating bodies. As the speed differential increased, small eddies formed along the edges of the jet stream, growing larger and stronger, forcing the circular flow into polygonal shapes. By adjusting the rotation rate, the researchers could produce triangles, squares, pentagons, and hexagons. The number of sides depended on the ratio between the inner and outer rotation speeds. Saturn's atmospheric conditions happened to favor a six-sided figure. The experiment demonstrated that there is nothing supernatural about the hexagon. It is a natural consequence of fluid dynamics on a rotating sphere, but the fact that it can be explained does not make it less extraordinary. A laboratory polygon in a water tank is a few centimeters across and lasts for minutes. Saturn's hexagon is 30,000 kilometers across and has lasted for at least 40 years without any sign of decay. The physics is the same. The scale is incomprehensible. Saturn's south pole, by contrast, does not have a hexagon. But it does have a polar vortex of its own, and what Cassini found there was, in some ways, even more unsettling than the hexagon, because it looked like something familiar and turned out to be something entirely alien. The southern polar vortex is a massive cyclonic storm with a well-defined eye that spans roughly 8,000 kilometers in diameter. When Cassini's instruments first imaged it in detail, scientists were struck by how closely it resembled a terrestrial hurricane. The eye was clear and sharply defined. The spiral cloud bands wrapped inward toward the center with the same organized rotation seen in tropical cyclones on Earth. The wall clouds surrounding the eye towered above the surrounding atmosphere. If you stripped away the context and showed the image to a meteorologist without telling them what planet it came from, many would identify it as a hurricane. But it is not a hurricane. It cannot be a hurricane. Hurricanes on Earth are powered by a very specific mechanism. Warm ocean water evaporates into the atmosphere, carrying latent heat upward. That heat is released when the water vapor condenses into clouds, driving convective circulation that powers the storm's rotation, The entire process depends on a warm ocean surface. Saturn has no ocean surface. Saturn has no surface at all. The southern polar vortex is driven entirely by atmospheric dynamics and the planet's internal heat, sustained by processes that have no equivalent on Earth. It draws energy not from a warm sea below, but from the vast thermal reservoir of Saturn's deep interior, channeled upward through convective processes that operate on scales and at depths that terrestrial meteorology has never encountered. This southern vortex was the first warm polar vortex ever discovered anywhere in the solar system. Temperatures at its center reach approximately -122 degrees Celsius, which sounds brutally cold but is significantly warmer than the surrounding atmosphere. The warm core is driven by adiabatic heating as air descends into the vortex, compressing and warming as it sinks. The result is a hurricane-shaped storm, thousands of kilometers across, with no ocean beneath it, powered by processes we do not fully understand, that has persisted for at least as long as we have been able to observe it, and possibly for far longer. It is a familiar shape, wrapped around an alien mechanism. Saturn's deception is written into the weather at its pole. The asymmetry between the two poles is itself a mystery. A study published in January 2026 by MIT researchers Jiaru Shi and Wanying Kang found that the type of polar vortex a gas giant develops depends on the properties of the gas at the base of the vortex. The hardness or softness of the atmospheric floor, meaning the density of the deeper gas layers, determines whether a single large vortex or multiple smaller vortices will form. This means that the hexagon is not just an atmospheric curiosity, it is a window into the hidden structure of the planet itself. Now, consider what all of this means together. You have a planet whose equatorial winds permanently blow at 1,800 kilometers per hour, whose mid-latitude jet streams alternate in direction at hundreds of kilometers per hour, grinding against each other in shear zones that generate vortices larger than Earth, whose north pole is capped by a geometrically precise hexagonal jet stream 30,000 kilometers across, containing a central vortex with no ocean to feed it, and substorms twice the size of any hurricane Earth has ever produced, whose atmosphere erupts every few decades in convective explosions so powerful they wrap the entire planet in storm clouds, produce lightning thousands of times more energetic than anything on Earth, and send temperature spikes racing through the stratosphere, whose everyday thunderstorms, even between major eruptions, produce lightning that cooks the atmosphere into soot and exotic organic compounds at 30,000 degrees, whose internal heat source is so powerful that the planet radiates far more energy than it receives from the sun, powered from within by processes that have been operating since its formation and that reach into the deepest layers of its structure. This is the weather on Saturn. This is what hides beneath the soft gold bands and the pastel stripes and the elegant ring shadows. And yet none of this, not the winds, not the storms, not the hexagon, not the lightning, is the most frightening thing about Saturn's atmosphere. The most frightening thing is what happens when you keep falling, because everything described so far occurs in the uppermost layer of the planet, the thin, visible, photographable skin. Below the ammonia ice clouds, there is another cloud deck, and below that, another. And below those clouds, the atmosphere does not end. It thickens, it darkens, it heats, and it transitions into something that is no longer atmosphere in any sense you would recognize. The next layer down is the ammonium hydrosulfide cloud deck, sitting at pressures of roughly 2 to 4 bars and temperatures that have climbed significantly from the ammonia cloud tops above. These clouds are darker, denser, and completely hidden from any camera ever aimed at Saturn. Below the ammonium hydrosulfide layer lies the water cloud deck at pressures of approximately 10 to 20 bars. This is the layer where the great white spot storms are thought to originate. The water clouds sit deep enough that no sunlight penetrates to them. They exist in total darkness, heated from below by Saturn's internal warmth, and the convective energy stored in this layer is what eventually breaks through the upper atmosphere every few decades in the eruptions described above. Below the water clouds, there are no more clouds. There is only gas, hydrogen and helium, thickening steadily with depth, the pressure climbing, the temperature rising, and the light gone completely. You are now in a world of permanent night. No stars, no sun, no horizon, just pressure and heat and the roar of winds you can no longer see. And you are still in what scientists would technically call the atmosphere. You have not reached any boundary. You have not hit any surface. You have not transitioned into anything that could be called the interior. Because Saturn has no sharp boundary between atmosphere and interior. The gas simply becomes denser and denser until at some point, without any dramatic transition, it is no longer a gas, it is a liquid. And deeper still, it becomes something else entirely. That transition is where the next part of this story takes you, into the darkness below the clouds, where hydrogen stops behaving like anything you have ever encountered and becomes a substance so strange it only exists in the cores of giant planets and in the most extreme laboratory conditions humans have ever created. Where helium separates from hydrogen and falls like rain through an ocean of liquid metal. Where the pressure reaches millions of atmospheres and the temperature climbs to tens of thousands of degrees, Saturn's atmosphere was the warning. What lies beneath it is the sentence. Below the clouds, there is no light. This is the first thing you need to understand about what lies beneath Saturn's visible surface. The pastel bands, the golden stripes, the soft colors that define every photograph you have ever seen of this planet exist in a layer so thin relative to the total depth of the world beneath them that they are comparable to the skin on an apple. Below that skin, sunlight fails. Photons from the distant sun, already weak at Saturn's orbital distance of nearly 1.5 billion kilometers, are absorbed and scattered by the thickening atmosphere within the first few hundred kilometers of depth. Beyond that, there is only darkness, permanent, absolute, total darkness. And into that darkness, the atmosphere continues downward for tens of thousands of kilometers, growing hotter, denser, and stranger with every meter of descent. You are about to take a journey that no spacecraft has ever attempted and none ever will. Not because we lack the ambition, but because the destination does not allow visitors. There is no landing. There is no arrival. There is only a deepening of conditions that progresses, without any clear boundary, from hostile to lethal to physically impossible to survive by any technology that exists or could be imagined with current science. You are going to fall into Saturn, and you are never coming back. Begin at the water cloud deck, roughly 10 to 20 bars of pressure where the great white spot storms originate. You are already deeper than any probe has ever ventured into a gas giant's atmosphere. The temperature here has climbed from the frigid -189 degrees Celsius of the upper stratosphere to something approaching room temperature, perhaps 0 to 30 degrees Celsius, depending on the exact depth and latitude. The warmth is not coming from the sun. It is coming from below. Saturn radiates approximately 87% more energy than it absorbs from sunlight. The planet is powered from within, heated by processes deep in its interior that have been operating for 4.5 billion years and show no sign of stopping. At this depth, you are surrounded by water clouds in total darkness. The clouds are not like any clouds you have experienced on Earth. They exist at pressures many times higher than sea level on Earth, in an atmosphere of hydrogen and helium laced with ammonia, ammonium hydrosulfide, and other compounds. The convective updrafts that occasionally punch through these water clouds and erupt into the upper atmosphere are the source of the great white spot storms described earlier. The energy stored at this level, accumulated over decades of suppressed convection, is what drives those planet-encircling eruptions. You are sitting inside the loaded spring. Keep falling. At roughly 100 bars of pressure, 10 times the depth of the water clouds, the temperature has risen to several hundred degrees Celsius. The hydrogen around you is still a gas, technically, but it is no longer behaving the way any gas behaves in your experience. It is dense, thick, resisting your passage in a way that feels more like moving through a fluid than through air. The distinction between gas and liquid is beginning to blur. On Earth, there is a clear boundary between a gas and a liquid. Water boils at 100 degrees Celsius at sea level, and there is a visible transition, bubbles forming, steam rising. The change of state is obvious. On Saturn, no such transition occurs. This is one of the most alien features of Saturn's interior. Hydrogen, at the temperatures and pressures found inside Saturn, exists as what physicists call a supercritical fluid. Above a certain combination of temperature and pressure, called the critical point, the distinction between liquid and gas ceases to exist. There is no boiling, there is no condensation. There is no surface tension, no meniscus, no boundary between phases. The material simply changes density gradually as conditions change. It flows like a liquid, compresses like a gas, and fills its container uniformly. It is both and neither. As you descend through Saturn's interior, the hydrogen around you transitions smoothly from a thin gas at the cloud tops to a dense supercritical fluid, and eventually to a state that behaves for all practical purposes like a liquid, without ever passing through a phase boundary. There is no moment where you cross from the atmosphere into the ocean. There is no splash. There is no surface. The sky just becomes the sea, gradually, imperceptibly, one molecule at a time. This gradual transition is one of Saturn's most disorienting features. On Earth, boundaries are everywhere. The ocean has a surface. The atmosphere has a ground. Rock meets air at a cliff face. Ice meets water at a melting point. The human brain is built to navigate a world of boundaries, to know when it has crossed from one medium to another. Inside Saturn, there are no boundaries. There is only gradient. The pressure increases continuously. The temperature increases continuously. The density increases continuously. If you were somehow able to survive the descent, you would never be able to point to a moment and say, "Here is where the atmosphere ended and the interior began." You would simply notice, gradually, that the medium around you had become something different from what it was 1,000 kilometers above, without ever being able to identify the moment of change. It is an environment that violates one of the most basic assumptions the human mind makes about physical space, that things have edges. By the time you reach a depth of approximately 1,000 kilometers below the cloud tops, the pressure is around 1 kilobar, roughly 1,000 times the atmospheric pressure at sea level on Earth, and the temperature has climbed to roughly 700 degrees Celsius, approaching 1,000 kelvins. The hydrogen is now a hot, dense fluid. It is transparent, but thick. Moving through it would feel like moving through syrup, except the syrup is at 700 degrees and pressing on every square centimeter of your body with the weight of 1,000 atmospheres. No known material could survive these conditions for any meaningful duration. Every alloy, every ceramic, every composite ever engineered by human civilization would deform, weaken, and fail. But you are only a fraction of the way down. Keep falling. At approximately 20,000 kilometers below the cloud tops, roughly 1/3 of the way to Saturn's center, the pressure reaches approximately 1 megabar, 1 million times the atmospheric pressure at sea level on Earth. The temperature is approximately 6,000 degrees Celsius, which is comparable to the surface temperature of the Sun. And here, something happens to hydrogen that has no analog in any experience available on Earth's surface. Hydrogen becomes a metal. Under ordinary conditions, hydrogen is the simplest element in the universe. One proton, one electron. It forms a diatomic molecule, two atoms bonded together, that is a colorless, odorless, extremely light gas. It is the most abundant element in the cosmos. It is the fuel that stars burn. And at pressures exceeding 1 megabar and temperatures of thousands of degrees, it undergoes a phase transition so profound that it becomes an entirely different substance. At these pressures, the molecular bonds between hydrogen atoms break. The electrons, which normally orbit their individual protons in neat, predictable shells, are stripped free and become delocalized. They flow through the material as a shared electron sea, exactly the way electrons flow through the lattice of a metal like copper or iron. The hydrogen becomes electrically conductive. It reflects light. It behaves, in every measurable way, like a liquid metal. This is metallic hydrogen. It is one of the most exotic states of matter known to science. It was first predicted theoretically in 1935 by Eugene Wigner and Hilliard Bell Huntington, and it has been produced in laboratory experiments only at extreme pressures using diamond anvil cells, for fractions of a second, in quantities too small to see with the naked eye. On Earth, metallic hydrogen is a laboratory curiosity, achieved at the very limits of what our equipment can produce. To create metallic hydrogen in a laboratory, physicists must squeeze a tiny sample of hydrogen between two diamond tips, the hardest natural material known, and compress it to pressures exceeding several million atmospheres. The diamonds themselves sometimes shatter under the stress. The sample volumes are measured in cubic micrometers. The metallic state, when it is achieved, lasts only as long as the pressure is maintained, and the moment the diamonds are released, the hydrogen reverts to its ordinary molecular form. Entire research careers have been devoted to producing and studying this material for fractions of a second in quantities invisible to the naked eye. Saturn produces it effortlessly. Not in a laboratory, not in a tiny sample, not for a fraction of a second. Saturn produces metallic hydrogen in an ocean that extends for tens of thousands of kilometers in every direction, under pressures that are maintained continuously by the weight of the planet above, at temperatures that would vaporize the diamond anvils used in terrestrial experiments. The substance that represents the absolute frontier of human material science is the ordinary background medium of Saturn's interior. It has existed there for 4.5 billion years and will continue to exist there for billions more. What we struggle to create for a nanosecond, Saturn maintains for aeons. Inside Saturn, metallic hydrogen is the dominant material. It fills the interior of the planet from roughly 1/3 of the way down to the center. It is not a thin layer. It is not a curiosity. It is the bulk of the planet. Saturn is, in the most literal sense, a ball of liquid metal wrapped in a shell of gas, and this liquid metal ocean is doing something. It is generating Saturn's magnetic field. The same principle that produces Earth's magnetic field, the dynamo effect, operates inside Saturn, but through a completely different medium. On Earth, the dynamo is driven by convective currents in the planet's outer core, which is made of molten iron and nickel. On Saturn, the dynamo is driven by currents in the metallic hydrogen layer. As the electrically conductive fluid moves, it generates electrical currents, and those currents generate a magnetic field. Saturn's magnetic field is weaker than Jupiter's, but has a magnetic moment 580 times greater than Earth's, owing to the planet's vastly larger size. But Saturn's magnetic field has a peculiarity that has puzzled scientists for decades. It is almost perfectly aligned with the planet's rotation axis. On Earth, the magnetic axis is tilted roughly 11 degrees relative to the spin axis. On Jupiter, the tilt is approximately 10 degrees. On Saturn, the tilt is less than 1 degree. The field is so symmetrical, so perfectly aligned with the rotation, that for years scientists struggled to explain how a dynamo could produce such a clean signal. Dynamo theory predicts that perfectly axially symmetric fields should not be self-sustaining. Something about Saturn's interior must be imposing this symmetry. The answer involves what is happening in the layer between the metallic hydrogen ocean and the molecular hydrogen envelope above it. And what is happening there is one of the strangest phenomena in all of planetary science: helium rain. Saturn's atmosphere is approximately 96% hydrogen and 3% helium, with the rest made up of trace gases. But measurements by Voyager and Cassini showed that Saturn's upper atmosphere has less helium than expected, based on the primordial composition of the solar nebula from which the planet formed. The helium has gone somewhere. It has gone down, at pressures of approximately 1 to 9 megabars, in the zone where molecular hydrogen transitions to metallic hydrogen. The two elements that have been mixed together since Saturn's formation begin to separate. Helium, which dissolves readily in molecular hydrogen, becomes immiscible in metallic hydrogen at certain temperatures and pressures. The helium separates out of the mixture the way oil separates from water. It forms droplets, and those droplets, denser than the surrounding metallic hydrogen, fall. If you could somehow exist in this layer, what you would witness would be unlike any weather on any world you have ever imagined. You are suspended in a medium that is not a gas, not a liquid, and not a solid, but a supercritical metallic fluid, electrically conductive, searingly hot, pressing on you from every direction with the force of millions of atmospheres. There is no light, except possibly a faint thermal glow from the medium itself, heated to thousands of degrees. And through this glowing metallic darkness, dense blobs of helium are separating from the hydrogen around you, coalescing into droplets that are heavier than their surroundings, and sinking slowly, imperceptibly, not falling the way rain falls on Earth, driven by gravity through empty air, but settling the way a heavy liquid settles through a lighter one, oozing downward through a medium so thick that the concept of falling barely applies. The helium does not splash, it does not patter. It drifts, pulled by gravity through an ocean of liquid metal in total silence, in total darkness, at temperatures that would destroy any known material, in a process that has been continuing without interruption since before the first multicellular organism appeared on Earth. They rain downward through the metallic hydrogen ocean. Slowly, over geological time, helium droplets settle deeper and deeper into the planet's interior, accumulating in the deeper layers and eventually reaching conditions where the helium itself becomes metallic and dissolves back into the metallic hydrogen. The process is extraordinarily slow. It has been operating for billions of years, and it has two profound consequences. First, it generates heat. As the helium droplets fall, they convert gravitational potential energy into kinetic energy, and friction converts that kinetic energy into thermal energy. This is the mechanism that explains why Saturn radiates so much more energy than it absorbs from the Sun. The excess luminosity that has puzzled scientists for decades is powered by helium rain. Saturn is literally glowing because helium is falling through its interior like slow precipitation through an ocean of liquid metal 4.5 billion years old. Second, the helium rain layer affects the magnetic dynamo. Research published in AGU Advances proposed that the thick helium rain zone creates a statically stable layer that confines and shapes the dynamo operating in the metallic hydrogen below. The settling of helium through this layer, combined with the heat transport within it, may be what forces Saturn's magnetic field into its unusually symmetric alignment with the rotation axis. The helium rain is not just a passive process. It is actively structuring one of the planet's most fundamental physical properties. A 2024 study on the fuzzy cores of Jupiter and Saturn, published in AGU Advances, further illuminated the picture. The researchers found that Saturn's helium gradient is extensive, spanning a wide range of pressures from approximately 1 to 9 megabars, and that the planet may possess what they describe as a helium ocean, a region in the deep interior where the helium mass fraction approaches unity. Saturn's interior is not a simple layered structure. It is a complex gradient of composition, temperature, and pressure, with helium settling and accumulating at depth in ways that fundamentally alter the planet's thermal evolution and magnetic behavior. Now go deeper still, past the helium rain layer, past the metallic hydrogen ocean, toward the center. At the heart of Saturn, there is believed to be a core, but it is not a core in the way most people imagine. It is not a neat ball of rock and iron sitting at the center of the planet like a pit inside a peach. The evidence from Cassini's gravity measurements, obtained during the spacecraft's grand finale orbits when it passed between the planet and its innermost ring, suggests that Saturn's core is what scientists call diffuse or fuzzy. Rather than a sharp boundary between a dense rocky core and the hydrogen-helium envelope above, the transition is gradual. Heavy elements, including rock and ice, are mixed into the hydrogen and helium in a gradient that extends outward from the center to perhaps 60% of the planet's radius. The gravity data alone did not reveal this. It was confirmed and refined by a technique so elegant it deserves its own explanation, because it connects the most beautiful feature of Saturn to the most hidden part of its interior. Saturn's rings act as a natural seismometer. Waves propagate through Saturn's interior in the same way that seismic waves propagate through the Earth after an earthquake. These internal oscillations cause tiny gravitational perturbations that ripple outward and disturb the ring particles orbiting above. The disturbances appear as spiral density waves in the rings, patterns of compression and rarefaction that can be measured with extraordinary precision from a spacecraft in orbit. By analyzing the wavelengths, frequencies, and locations of these ring waves, scientists can infer the oscillation modes of Saturn's interior, which in turn constrain the density structure deep inside the planet. This technique, called ring seismology or chronoseismology, was used by Christopher Mankiewicz and Jim Fuller at Caltech to probe Saturn's deep interior. Their analysis of Cassini ring data revealed that the transition between Saturn's heavy element core and its hydrogen-helium envelope is not sharp, but extends across a vast region. With approximately 17 Earth masses of ice and rock mixed through the interior out to roughly 60% of the planet's radius. The total heavy element content of Saturn may be as high as 20 to 30 Earth masses, but much of it is distributed throughout the interior rather than sitting neatly at the center. The precision of this technique is remarkable. By measuring the locations and properties of dozens of spiral density waves in the C-ring, researchers identified specific oscillation modes of Saturn's interior. Each mode corresponds to a different pattern of internal vibration, and the frequency of each mode depends on the density and composition of the material through which it propagates. The ring waves act as a readout of these frequencies, translated into spatial patterns that Cassini's cameras could resolve. It is, in effect, reading the planet's internal structure by watching its rings wobble. No other method currently available to planetary science can probe the deep interior of a gas giant with comparable directness. There is something almost poetic about this. The rings, the most celebrated feature of Saturn, the structure that defines the planet in every human imagination, are also the instrument through which scientists discovered the nature of the abyss below. The beauty is, quite literally, the lens through which we see the horror. The rings vibrate in response to the planet's internal oscillations, and those vibrations tell us that beneath the golden clouds lies a diffuse, gradientless descent into compressed rock and metal under conditions that no material on Earth could survive. The conditions at Saturn's core are almost beyond description. The pressure is estimated at roughly 10 to 20 megabars, 10 to 20 million times the atmospheric pressure at sea level on Earth. The temperature is estimated to be between 10,000 and 20,000 degrees Celsius. At these conditions, the distinction between what constitutes rock, ice, metal, and hydrogen becomes academic. Materials that are familiar solids on Earth's surface exist in exotic high-pressure phases that bear no resemblance to their ordinary forms. Water, if present, would not be a liquid, a solid, or a gas. It would be a superionic form in which oxygen atoms are locked in a crystalline lattice while hydrogen ions flow freely through it like a current. Any spacecraft sent to Saturn's core would not merely be destroyed. The concept of destruction does not adequately capture what would happen. The vehicle would be compressed, heated, chemically dissociated, and incorporated into the surrounding material. Its atoms would join the gradient. It would become part of Saturn, indistinguishable from the native material, in a process that would take less time than it takes to draw a breath. This is what lies beneath the golden clouds. This is what the photographs do not show, not because anyone is hiding it, but because no photograph can capture it. No camera operates in the dark. No lens survives the pressure. No instrument functions at the temperature. The interior of Saturn is known to science only through indirect measurement, through gravity data from orbiting spacecraft, through ring seismology that uses waves in Saturn's rings as a natural seismometer to probe the planet's deep structure, and through theoretical models constrained by laboratory experiments at extreme pressures. What those methods have revealed is a planet that is, in the most fundamental sense, an abyss. A layered abyss, with each layer more hostile, more alien, and more impossible to survive than the one above it. The upper atmosphere is a hurricane factory. The middle layers are a supercritical ocean of hydrogen hot enough to glow. The deep interior is a sea of liquid metal generating electromagnetic fields, while helium rains through it in a process that has been converting gravitational energy to heat since before complex life existed on Earth. And at the center, a fuzzy mass of rock and ice compressed under conditions that exist nowhere else in the solar system except inside Jupiter. And the entire structure, from cloud tops to core, is spinning, completing one full rotation every 10 hours and 42 minutes. The equatorial regions bulge outward from centrifugal force. The deep interior rotates as a single body, locked to the rhythm detected in radio emissions and mirrored in the rotation of the hexagonal polar vortex 30,000 kilometers above. The planet is a single integrated machine. From the ammonia ice crystals catching faint sunlight at the top to the metallic hydrogen dynamo churning in the dark at the bottom. All of it connected, all of it driven by gravity, rotation, and the remnant heat of formation. Think about the journey you have just taken. You began at the top of Saturn's atmosphere, floating in thin hydrogen at minus 189 degrees, looking down at clouds made of frozen ammonia crystals, colored gold by trace impurities. You descended through those clouds into the ammonia ice layer, past the ammonium hydrosulfide deck, into the water clouds sitting in total darkness. You continued through thickening hydrogen that smoothly transitioned from gas to supercritical fluid to liquid without ever passing through a phase boundary. You reached the depth where hydrogen becomes a metal, an electrically conducting liquid that fills the bulk of the planet's interior. You passed through the helium rain layer, where droplets of liquid helium separate from the metallic hydrogen and fall slowly toward the core, releasing gravitational energy as heat. And you arrived at the diffuse core, a gradient of rock, ice, and exotic high-pressure materials compressed under millions of atmospheres and heated to tens of thousands of degrees. At no point during that journey did you encounter a surface. At no point did you find a boundary you could stand on, a floor you could touch, a wall you could push against. There was no moment where the sky ended and the ground began. There was only a continuous deepening, a gradual thickening of conditions, a slow escalation from merely lethal to physically inconceivable. This is what Saturn is, not a place, not a world in any sense that the word implies to human intuition. It is a process, a compression, a gradient that begins in thin, cold gas and ends in hot, dense metal, with nothing solid in between except possibly a smeared-out remnant of rocky material at the very center, itself compressed into forms that no human has ever held or seen, and the entire structure emits more energy than it receives. Saturn glows, not with the light of nuclear fusion, the way a star glows. It glows with the heat of its own contraction and the slow differentiation of helium falling through its interior. It has been glowing this way for 4.5 billion years. It will continue glowing for billions more, slowly cooling, slowly contracting, slowly settling toward a final equilibrium that it may never reach before the sun itself exhausts its fuel. A 2024 study published in Nature Communications confirmed that Saturn's global energy budget is not in a steady state. The planet exhibits significant dynamical imbalances, with the radiant energy deficit at the top of the atmosphere fluctuating seasonally by roughly 16%. Saturn is not simply cooling passively. It is actively managing its internal heat through processes that vary with its orbit around the Sun, that interact with its ring system, and that couple to the deep atmospheric circulation patterns visible at the surface. The planet is thermally alive, adjusting and responding to conditions on time, scales that span decades, in ways that researchers are only beginning to quantify. The planet you see in photographs, the one with the golden bands and the elegant rings, is the thinnest possible shell stretched over this abyss. It is the surface of a depth that has no bottom in any meaningful sense. It is a face painted on darkness. And the darkness beneath it is hotter, denser, more violent, and more alien than almost anywhere else in the solar system. You have now seen what lies beneath the beauty. What remains is to pull back to the full picture, the rings, the moons, the system that surrounds Saturn. And it will ask the question that has been building since the first sentence of this script. Why does beauty make us trust something we should fear? Why does the most visually perfect planet in the solar system hide one of the most hostile realities ever measured? And what does Saturn tell us about the places in the universe that look the most welcoming from a distance? The answer is not comfortable, but it is the truth. And the truth about Saturn is that its beauty was never meant for you. Pull back now. Rise out of the darkness. Leave behind the crushing pressures and the metallic hydrogen ocean and the helium rain falling through depths no light has ever reached. Come back to the surface, if you can call it that. Come back to the cloud tops, to the thin, visible shell, to the place where cameras can operate, and photographs can be taken, and human eyes can look at Saturn and feel something close to peace. Because now, with everything you know about what lies beneath, you need to look at Saturn again. You need to see the whole picture, not just the planet, but the system, the rings, the moons. The gravitational empire that Saturn governs across a volume of space larger than any kingdom ever imagined by any civilization in human history. And you need to understand that the deception does not end with the atmosphere. It extends outward, into every part of Saturn's domain, written into the very structures that make this planet the most visually celebrated object in the solar system. Start with the rings. Saturn's rings are the single most iconic feature of any planet in the solar system. They are the reason Saturn is the planet every child can identify. They are the reason Galileo stopped what he was doing in 1610 and stared through his telescope in confusion, seeing what he described as ears or handles on a world that should have been a simple sphere. They are the reason Christian Huygens made his name as an astronomer, and the reason Giovanni Cassini's legacy is carved into the nomenclature of planetary science. The rings are gorgeous. They are geometric. They are vast, stretching up to 282,000 kilometers from the planet, wider than the distance between the Earth and the Moon. And they are so thin relative to their width that when they turn edge onto Earth every 13 to 15 years, they virtually disappear. The main rings are roughly 30 feet thick on average. 30 feet across a span of nearly 300,000 kilometers. They look eternal. They look like they have always been there and always will be. They feel like a permanent feature of the solar system, as fixed as the sun or the orbit of the Earth. They are not. Saturn's rings are dying. Research published in Science Advances in 2023, using data from Cassini, constrained the age of the rings to no more than a few 100 million years. The rings are young, cosmically, shockingly young. Saturn is 4.5 billion years old. The rings may have formed as recently as 100 million years ago. Dinosaurs were already walking the Earth when Saturn's rings came into existence. The rings are not a primordial feature of the planet. They are a recent addition, likely formed when a comet or icy moon strayed too close to Saturn and was torn apart by tidal forces, its material spreading into the flat disk of ice and rock that now encircles the planet. And they are not just young, they are disappearing. NASA research confirmed that Saturn is losing its rings at what scientists described as the worst-case scenario rate. A phenomenon called ring rain pulls electrically charged ice particles from the rings down into Saturn's atmosphere along the planet's magnetic field lines. James O'Donoghue, the NASA scientist who led the research, estimated that ring rain drains enough water to fill an Olympic-sized swimming pool every half hour. Combined with material falling directly into Saturn's equator, as measured by Cassini during its grand finale orbits, the rings may have less than 100 million years to live. Some estimates extend this to 300 million years, but either way, the conclusion is the same. The rings are temporary. They are already past their prime. They are fading. This means that the feature most responsible for Saturn's beauty, the feature that defines the planet in every image and every imagination, is a fleeting accident, a cosmic blink, a debris field that appeared recently and is already on its way out. If intelligent observers had looked at Saturn a few 100 million years earlier, they would have seen a ringless gas giant, unremarkable in appearance compared to Jupiter. If observers look at Saturn a few 100 million years from now, they will see the same thing. The rings exist in a narrow window of time, and we happen to live inside that window. We are lucky enough to see them. We are also foolish enough to mistake them for permanence. And the rings themselves are not the serene, delicate structures they appear to be. They are a story written in destruction. Cassini revealed that the rings are composed of billions of individual chunks of ice and rock, ranging in size from grains of dust to boulders as large as houses. These particles orbit Saturn at different speeds depending on their distance from the planet, with inner particles moving faster than outer ones. The entire system is dynamic, churning, interacting. Tiny shepherd moons embedded within the rings carve gaps and create edges through gravitational perturbation. The F ring, Saturn's outermost discrete ring, is twisted and kinked by the gravitational influence of the moon Prometheus, which passes close enough to pull streamers of material from the ring on every orbit. The ring particles collide with each other constantly, grinding, fragmenting, and occasionally clumping together before being pulled apart again. The Cassini division, the wide gap between the A and B rings that Giovanni Cassini first observed in 1675, is maintained by an orbital resonance with the moon Mimas. Particles that stray into the division are gravitationally nudged by Mimas into unstable orbits that eventually clear them from the gap. The rings are sculpted by violence. Every gap, every edge, every wave pattern visible in high-resolution Cassini images is the result of gravitational forces tearing, pulling, and reshaping material that is itself the remnant of something that was destroyed. The beauty of the rings is the beauty of wreckage. Frozen wreckage, illuminated by distant sunlight, arranged by gravity into patterns so geometrically precise that they look intentional. But they are not intentional. They are the result of tidal destruction and gravitational sorting, the same forces that would tear apart any object, including a spacecraft, including a human body, that ventured too close. Now look beyond the rings, to the moons. Saturn has more than 140 known moons, with recent surveys pushing the count past 280 when the smallest irregular satellites are included. The system is enormous, diverse, and in many ways more complex than the planet itself. And two of those moons, the two most famous, carry their own versions of Saturn's central deception. They look like one thing and are, in reality, something profoundly different. Enceladus is a small moon, only about 500 kilometers in diameter, roughly the size of the British Isles. It is coated in fresh, bright ice that makes it one of the most reflective objects in the solar system. From a distance, it looks pristine, clean, frozen, solid, dead. It is not dead. Cassini flew through plumes of water vapor and ice particles erupting from cracks near Enceladus's south pole and discovered that beneath the moon's icy surface lies a global ocean of liquid, salt water. The ocean is heated by tidal forces generated by Saturn's gravitational grip. As Enceladus orbits Saturn, the planet's gravity flexes and deforms the moon's interior, generating friction that produces enough heat to maintain liquid water beneath a shell of ice. The plumes shooting from the surface carry water, organic molecules, molecular hydrogen, and silica nanoparticles. The silica particles are particularly significant. On Earth, silica nanoparticles of the size detected by Cassini's cosmic dust analyzer are produced in only one known environment: hydrothermal vents on the ocean floor, where superheated water interacts with rock at temperatures of at least 90 degrees Celsius. The presence of these particles in Enceladus's plumes implies that the moon has hot water chemistry at the bottom of its ocean, rocky material in contact with heated water, and conditions that on Earth support thriving ecosystems of chemosynthetic organisms clustered around volcanic vents in the deep sea. The molecular hydrogen detected in the plumes adds another layer. On Earth, hydrogen is produced by hydrothermal reactions between water and iron-bearing minerals at high temperatures, a process called serpentinization. The hydrogen produced by this process is consumed by methanogenic archaea, microorganisms that form the base of food chains in deep ocean ecosystems where sunlight never reaches. The detection of molecular hydrogen on Enceladus means that the energy source required to sustain such organisms is present. The chemical ingredients are there. The energy is there. The liquid water is there. In 2011, NASA scientists declared that Enceladus was emerging as the most habitable place beyond Earth in the solar system for life as we know it. That statement came from data collected by a spacecraft studying Saturn, the planet most people associate with beauty and elegance, not biology. The most promising lead in the search for extraterrestrial life in our solar system is orbiting the scariest planet in it, kept alive by the gravitational violence of a world that would destroy anything that entered its atmosphere. Enceladus's ocean exists because Saturn tortures it. The tidal heating that maintains liquid water is a direct consequence of Saturn's enormous mass and the orbital dynamics of the Saturnian system. Without Saturn's gravity flexing the Moon's interior, the ocean would freeze solid. Life, if it exists there, would die. The potential for biology on Enceladus is sustained entirely by violence. Every flex of the Moon's icy shell, every surge of tidal heat through its rocky core, every eruption of salt water through the surface cracks is powered by the same gravitational force that drives 1,800 km/h winds at Saturn's equator, crushes hydrogen into liquid metal in the planet's interior, and tears passing objects into ring debris. Saturn does not nurture life on Enceladus. It provides the energy for life as a byproduct of gravitational deformation, the same way a hydraulic press generates heat as a byproduct of crushing metal. The warmth is real. The indifference is total. The beauty and the violence are not separate things. They are the same thing, viewed from different distances. Titan tells a similar story, but stranger. Titan is Saturn's largest moon, larger than the planet Mercury, and the only moon in the solar system with a dense atmosphere. That atmosphere is roughly 1.5 times the surface pressure of Earth's and is composed primarily of nitrogen with a few % methane. It is so thick that it completely obscures the surface, surrounding the moon in an opaque orange haze that gives Titan the appearance of a smooth, featureless sphere. Cassini carried a radar instrument that could penetrate the haze, and the Huygens probe descended through Titan's atmosphere on January 14, 2005, landing on the surface and returning images of a landscape that looked hauntingly familiar. The descent took roughly 2 hours and 27 minutes. During that time, Huygens recorded the sound of Titan's winds, measured the temperature and pressure at every altitude, sampled the atmospheric chemistry, and photographed the approaching surface in increasing detail. What the cameras showed as the probe broke through the lower haze layer was a landscape of drainage channels, ridgelines, and what appeared to be a shoreline separating lighter highlands from a darker, flatter lowland. The channels branched and merged in patterns identical to river drainage networks on Earth. The darker lowland was smooth and flat, consistent with a dry lake bed or a flood plain. When Huygens touched down, it landed on a surface that yielded slightly beneath the probe, like wet sand or compacted snow. The surface camera revealed a scattering of rounded pebbles, each a few centimeters across, made of water ice so cold it was as hard as granite. The pebbles had been smoothed by flowing liquid, tumbled and rounded over time by the same erosional processes that shape river stones on Earth. Except the river that shaped them was not water. It was liquid methane, flowing at -179 degrees Celsius, carving channels through bedrock made of frozen water, in a landscape illuminated by sunlight, so faint it resembled a dim, overcast afternoon on Earth. But the rivers and rain on Titan are not water. They are liquid methane and ethane. At the temperatures Huygens measured, methane behaves the way water behaves on Earth. It evaporates, forms clouds, falls as rain, and collects in bodies of liquid on the surface. It rains from the sky. It pools in lakes and seas. Ligaea Mare, one of the largest hydrocarbon seas on Titan, contains enough liquid methane to dwarf the total petroleum reserves of Earth. Titan has weather cycles, erosion patterns, and seasonal variations that mirror Earth's hydrological cycle almost perfectly, except that the working fluid is a combustible hydrocarbon and the bedrock is frozen water ice that never thaws. Titan looks Earth-like. It has been described as the most Earth-like body in the solar system. And in terms of process, of weather, of geology shaped by flowing liquid and falling rain, that comparison is accurate. But the comparison disguises a reality so alien that it takes effort to hold both truths in your mind simultaneously. Titan is a world where the rocks are made of ice and the rain is made of fuel, where the atmosphere is thick enough to walk through comfortably in terms of pressure, but cold enough to kill you before you took your second breath, where the landscape looks like a coastline on Earth, but is composed of materials so foreign to terrestrial biology that no known organism could survive on the surface for any measurable duration. Titan is Saturn's atmospheric trick played on a moon. It looks familiar, it feels recognizable, and it is utterly, fundamentally, irreconcilably alien. The Huygens probe survived for roughly 90 minutes on the surface before its batteries died and its signal faded. In those 90 minutes, it returned the only images ever taken from the surface of a world in the outer solar system. The landscape it showed looked like it could have been a riverbed in northern Europe on an overcast winter day. The colors were muted, the pebbles were rounded, the horizon was flat. Everything about it invited the human brain to feel recognition, to feel at home. And every molecule of the environment would have killed a human being instantly. The familiarity is the cruelest part. If Titan looked as alien as it truly is, the brain would recoil. Instead, it relaxes. It sees home. And home is a frozen hydrocarbon wasteland where the rain is methane and the temperature is closer to absolute zero than to anything a living cell has ever experienced. This is the pattern. This is what Saturn does, not through intention but through physics. It presents beauty. It offers familiarity. It shows you golden bands and geometric rings and icy moons and hazy atmospheres that remind you of home. And beneath every one of those surfaces lies something hostile, violent, or alien beyond the capacity of human intuition to fully absorb. The question that remains is why this matters. Not as a scientific curiosity, but as something deeper. Why should you care that Saturn is not what it seems? Here is why. Humans navigate the world through pattern recognition. We evolved to assess threats and opportunities quickly, using visual cues as shortcuts. A landscape that looks green and lush signals water and food. A sky that darkens signals a storm. An animal that displays bright warning colors signals danger. Over millions of years, our brains developed an extraordinary capacity to read surfaces and draw conclusions about what lies beneath them. That capacity works beautifully on Earth. It fails completely in space. The universe does not color-code its dangers. It does not provide warning signals that align with human intuition. The most lethal environments in the solar system are not the ones that look the most threatening. Mars looks hostile, red and barren and dusty, and it is hostile, but a human in a pressure suit could survive on the surface for extended periods. Venus is shrouded in featureless white clouds that look almost gentle, and beneath those clouds is a surface hot enough to melt, lead under an atmosphere 90 times denser than Earth's. The sun looks warm and inviting, and it is a thermonuclear furnace that would vaporize any object that approached within millions of kilometers. Saturn is the most extreme version of this mismatch. No other planet in the solar system presents such a stark contrast between visual appearance and physical reality. Jupiter is visually turbulent. Its bands are bold, its colors are aggressive, and the great red spot advertises violence. When you look at Jupiter, you get a sense, however incomplete, that you are looking at something powerful and dangerous. Saturn gives you none of those signals. Saturn looks calm. Saturn looks refined. Saturn looks like the civilized member of the gas giant family. And Saturn will kill you faster and more completely than almost any other place in the solar system, not because it is more hostile than Jupiter in absolute terms, but because its hostility is better hidden. The winds are faster, but the clouds are softer. The storms are more explosive, but they erupt less frequently, hiding between decades of apparent calm. The interior is just as crushing, but the exterior gives no hint of it. The rings distract, the colors soothe. The geometry satisfies. This is not a metaphor, this is physics. Saturn's visual appearance is determined by the chemistry and temperature of a cloud layer less than 1% of the planet's total depth. Everything below that layer is invisible to optical observation. The beauty is real, but it is a boundary condition, a surface effect, a consequence of ammonia crystallizing at a particular temperature in a particular light. It has no relationship to the conditions a few hundred kilometers further down, where the beauty gives way to violence so extreme that it cannot be photographed, only calculated. And this is what Saturn teaches. Not as a lesson it intends to deliver, but as a fact its existence makes unavoidable. The most dangerous places are not always the ones that look dangerous. The most hostile environments do not always advertise their hostility. The universe is under no obligation to match its appearance to its nature. And the human instinct to trust beauty, to relax in the presence of elegance, to assume that something visually harmonious must be physically gentle, is an instinct that evolved for a small, warm, rocky world with liquid water and breathable air. It does not transfer to the cosmos. Saturn sits in the outer solar system 9.5 times further from the Sun than Earth, orbiting once every 29.5 years, spinning once every 10 hours and 42 minutes, radiating more heat than it receives, losing its rings to gravity, torturing its moons with tidal forces, generating a magnetic field from an ocean of liquid metal, and driving wind systems that have been operating without interruption for longer than multicellular life has existed on this planet. It does all of this while looking like a jewel. It does all of this while appearing in every textbook as the elegant one. It does all of this while children draw it with crayons, and adults hang photographs of it on their walls, and the entire species that has studied it most closely consistently describes it as beautiful. It is beautiful. That is not a lie. Saturn is genuinely, measurably, objectively, one of the most visually striking objects in the known universe. The rings are extraordinary. The proportions are remarkable. The colors are real. The geometry is precise. But beauty is not safety. Beauty is not gentleness. Beauty is not an invitation. Saturn does not want you to visit. Saturn does not know you exist. Saturn is a process, not a place. It is gravity and hydrogen and pressure and time, assembled into a structure so massive and so indifferent that the entire history of human civilization registers as less than a single rotation of its hexagonal polar vortex. The planet you admired from the classroom poster is a sphere. of violence disguised as elegance. The rings you drew with crayons are the frozen remains of something that was torn apart. The golden clouds you saw in Cassini's photographs are a curtain drawn across an abyss that has no floor. The moons that orbit in the ring plane carry oceans heated by gravitational cruelty and atmospheres made of fuel. Saturn is the scariest planet in the solar system, not because it is ugly, not because it is chaotic, not because it announces itself as dangerous. It is the scariest planet because it is the most beautiful. Because beauty, in this case, is the mask. Because the most welcoming face in the solar system belongs to one of the most hostile realities ever measured. Because when you look at Saturn and feel wonder, you are responding to a surface that has nothing to do with what lies beneath it. And because somewhere in the architecture of the human mind, there is a flaw, a tendency to trust what looks safe, to relax in the presence of symmetry, to mistake elegance for mercy, Saturn has no mercy. Saturn has no malice. Saturn has no awareness and no intent. It is a planet. It is a ball of gas and metal and pressure, old beyond comprehension, vast beyond intuition, and beautiful beyond anything the inner solar system can offer. And it would destroy you without noticing. Not because it is cruel, but because you are small, and it is not, and the universe does not owe you a warning sign that matches the danger. The next time you see a photograph of Saturn, you will see the golden bands. You will see the rings catching starlight. You will see the perfect shape, the soft colors, the quiet majesty that has captivated every generation of humans that has ever looked upward and wondered. And now you will also see the wind, the pressure, the darkness, the metal ocean and the helium rain and the storms that wrap the planet, and the lightning, thousands of times more powerful than anything on Earth, and the hexagonal vortex spinning over the pole, and the rings slowly dissolving into the planet. Atmosphere, and the moons cracked open by tidal forces, and the core crushed under millions of atmospheres at temperatures that rival the surface of a star. You will see all of it, the beauty and the horror. And you will understand that they are not opposites. They are the same thing. Saturn is terrifying because it is beautiful. And it is beautiful because the universe does not care whether you can tell the difference. That is the final lesson of the ringed planet. Not that space is dangerous. Every child knows that. Not that gas giants are inhospitable. That is obvious. The lesson is subtler and more unsettling. It is that the universe presents its most extreme dangers in packages that the human mind is specifically designed to find attractive. Golden colors, geometric symmetry, smooth curves, elegant proportions. These are the visual cues that evolution trained us to associate with safety, with order, with things that are under control. Saturn possesses all of them. And Saturn is a place where control does not exist, where order is an illusion painted on the outermost skin of chaos, and where safety is a concept that has no meaning below the first 100 kilometers of cloud. We built our understanding of beauty on a single world, a world with oceans and sunsets and flowers and symmetrical faces. We took those preferences with us when we looked at the sky, and we projected them onto objects that have no relationship to the conditions that created them. Saturn did not evolve to please us. It was not shaped by the same pressures that shaped our aesthetic sense. Its beauty is a coincidence, a collision between the physics of ammonia, crystallization, and the neurology of primate visual processing. And that coincidence has been powerful enough to distract an entire species from the reality of what lies beneath. The scariest planet in the solar system is the one that does not look scary. It is the one that looks like it belongs on a postcard. It is the one that makes you feel calm when you should feel afraid. And it has been doing this for as long as anyone has looked at it, through every telescope, from every spacecraft, in every photograph ever taken. Saturn is not what it seems. It never was. And now you know what it really is.